that being said, I want you to notice that there is 2 pieces of homework, but this piece is not going to be due tomorrow. The piece that's due tomorrow is the usual 71 to 83 odd, 85 to 91. Most of that's multiple choice. This is something that I just want you to be working on throughout the week. I just want you guys to turn it in before the day of the test. So if you want to be specific, which we probably should be, if you just want to make a little note there that that piece is going to be due 9/5, I will have the answers available for you. And if you want to just take a look at it real quick together, it's got basically a bunch of mixed normal CDF and inverse norm problems. This whole part is about Back to the Future. You guys know who Doc and Marty are? Yes? Okay, and then this part is kind of empirical rule mixed with normal CDF, mixed with inverse norm. Please stop, please. This last bit right here is the only part that you haven't learned yet. So you could do this whole worksheet right now, minus number 6. It says find the mean and standard deviation of the normal model, and that is what I need to teach you here. So this particular piece, this systems of equations to solve for mean and standard deviation, is technically supposed to go in the 2.2c section, but that day is just so important that I can't shove any more into it. So we move it to this day. Some of you guys have noticed that the chapter is over after today. This is the last thing you're learning for chapter 2. But I like to postpone a test till the following block week for a lot of reasons. So your test will be next week on the block day, 9/5, I believe. Anyway, okay. So first of all, do you remember the 3 different types of systems of equations? Yes, elimination and substitution and equal values method. Equal values is the other one. Equal values is really just substitution. So technically there's really only 2. This is going to be an elimination method problem. Okay, so there's actual like math algebra in math today. Whew. Okay. I want to draw a little picture over here. Before we do this. And so it says Congo peafowl are endangered and being studied by researchers. The 21st percentile. Okay, so where's my normal curve? I had it right here. Let's see, 21st percentile would be like, here's 16, so here-ish, right? Right about there. So I'm just gonna go, and that would be 0.21 21st percentile is 2.5389. That's a long thing. Okay, and then the 83rd percentile. So 84th is right here. I'm just gonna put that here-ish. Okay. Can you guys all see from my arrows that I'm implying that this little piece here is 21% and this whole shaded down region is 83%? Yeah. You see that the 83% and the 21% overlap each other. Okay. All right. So this is the information that we're given. And what we're going to do is figure out the mean and standard deviation of this. There is a formula that we use that has mean and standard deviation in it that we're going to use to help us solve. Does anybody know a formula with mean and standard deviation in it? Z-score. Exactly. So I'm going to use two Z-score formulas right next to each other to do a system of equations. Okay. My first step is that I need to find the Z-score of these two spots. And I did this on purpose on Friday. The very last example I did was finding a Z-score. So Z equals inverse norm. The area for this one is 0.21. And then because we're working with Z being standard normal, our mean and standard deviation are 0 and 1. Are you okay for time purposes if I just tell you what this is out of the calculator? Yeah. Okay. Okay, does this line right here, this dashed line, look like it's about negative 0.8 standard deviations from the mean? Do you understand what I mean by that? Like down one, almost one notch. Okay, now we're gonna do the other one, the 83%. Miss Rice came in, she looked at the page, she goes, man, the elimination method's easy, but these numbers are terrible. I'm like, that's stats for you, full of decimals. Okay, any questions about how I got these two Z-scores? You know why I used 0 and 1? Because I was solving for Z. Everybody good there? Okay, now I'm going to take this one and I'm going to fill in one of these. So Z is negative 0.806 equals, and then the X value at that spot is the 21st percentile is this 2.5389 minus the mean divided by standard deviation. Okay, 0.954 equals, what's X for this problem? 3.2027 minus the mean divided by standard deviation. Ooh, my standard deviation is not looking good in that one. It's fine though. Okay, everybody good. So I found the Z's and then I plugged the Z's in with the two X's they gave me in the problem. Notice mean and standard deviation are variables here. Okay, you guys okay? Okay, now I'm going to use just regular algebra solving techniques. I'm going to multiply both sides by standard deviation to clear the denominator. But when I do this, I'm going to write this one on the top. So let me show you. You see where the stuff went and what happened? Are you sure?
Yeah.
So this stuff went here, and then I just did, instead of having the variable in front, I did it after, like 2x. You know what I mean?
Yeah.
Okay. The good news about these is that you always have minus the mean, so we always subtract. You don't have to do an elimination method ever where you multiply one of the equations by something. They're always subtraction. The only problem is just remembering that it's subtraction. So this minus this is negative 1.76. And then you have to remember to do this minus this. And then the mu's cancel. So again, this minus this minus this. Okay. What? Oh, no, you would just get both of these to be positive instead of negative. Excellent question. You're going to get weird answers for them. That's just how staff works. Okay, but it's not even done. We found the standard deviation. Now we have to find the mean. And I'm just going to plug it into this. I'll plug it into, I don't know, I'll plug it into the top one here. No, it's just the top one I didn't mess with by subtracting. I'm just going to. What? Yeah, I multiplied those two to get this. If you want to, you can put a little, like. And they're both negative, so I made them positive. Okay. I have one for you to do. It's the next example 2 in the Mr. Talbot cut and paste section. So I want you guys to do this one in your group together. You do not need to draw a little picture and all of that. You can just, follow the steps through, just follow what I did for the first one. When you guys get situated, I'm going to put the answer up at the bottom. What I want you to do is fill in all the work from the start to the end. Okay, you guys. So there's the problem. There's the answer. The mean is 60.360 and the standard deviation is 3.450. Your job in the next 10 minutes is 7 minutes maybe to get from the problem to the answer. I'll walk around and help you. Go to 4 decimals, guys.
Wait a minute.
Real quick, make sure that you do the 5th percentile as 0.05, not 0.50. Percentile. The word percentile is why it's left. The word percentile is left. Yeah.
I didn't believe Bryce.
You said you were.
Yeah. Anytime it's a percentile, it's left. Percentile is over less than or equal to less. They're not always going to be left. It's just that this one has the words percentile in it.
No, you're good.
If it said more than, you would have two to the right. Four decimals will give you the best chance of matching my 3 decimals. Yeah, it says the word percentile on it, so. Nice.
No, you're good.
Board. Yep, yep. It just gives you the best chance to get match my 3 at the end, way around it. I don't want you to think that you're wrong when you get to the end of your decimal fluid. Just try to keep it to this. It's fine, though. It's not bad.
We're good. Just a minute.
He's more than up with the style.
Yeah. right answer.
How are you already done?
I got that one. Yeah, I got
Sigma, lowercase sigma.
yeah, I got that one. Just like, no way up.
The other one's called mu.
I had to replace that one.
Sigma.
You know what that is?
No, I knew that. I just like, I forgot. What?
Oh, I just sent it.
This guy just tried to tell me.
I got the SD. I got the
Just like 3 minutes. Yeah, run. Don't really run though, you'll trip. Okay, if you're, I see a bunch of you are done and just waiting. If you're done and just waiting, it's okay, just saying, if you're done and just waiting, that's what you do for the last bit.
Where'd the answer go? Yeah.
It was 60.360.
Is that right? 60, is that right?
Yeah, but for negative.
Oh, yeah,
And
but
it's negative mu. So,
Yeah.
yeah. And then the standard deviation is 3.45. Anyone need to know the answer? Speedier, speedier.
I'm very slow. I just did the whole problem.
3.45.
Yes. Where's my one? All right, champion prize, we have to say.
If you finish, set this up and then type these numbers into L1, please. If you think you're not gonna finish, leave some room.
I think so. I don't know if
So this should be negative. And then, yeah.
so. Yeah.
You got
Welcome back. Yeah, welcome back. Where's my? That's how I messed up. That was good. Welcome back.
My bad. 30, no, 60.36, 60.63, 60.36. Yeah. 60.36, this is escaping me already.
Excuse me.
Okay, so what you're doing right now is you're setting up your notebook for this. You are typing the numbers into L1 if you are done setting up your notebook. And to be honest, the whole class doesn't need to type the numbers into L1. You get one or two numbers, that'd be great.
I'm switching the portrait myself. No, it's not.
Have like 2 more seconds and you're going to have to abandon ship on that systems problem and finish it later.
Why are you still on that one? Why are you still there?
Anyone in your group have a type? He does, okay. James is typing it in.
Yeah.
Okay.
Thank you, James.
Okay. Moving on. If you need help with the systems problem, stay after. Okay. The last thing in the chapter, guys, is we need to be able to take a data set, so just a set of numbers, and tell if it's normal or not. And so that we can use normal CDF and stuff on it. There are 3 ways to tell. First is the data is bell-shaped and symmetric. Okay, here's the thing. Usually when you have a data set, that's from a sample. So it's not going to be perfect. When you guys make a histogram or box plot from a set of data, you should know that that's not all the numbers. You should know that that's a sample. This is 20 numbers from a sample. So what we're looking for is basically, can we rule out normality? So I want you guys to look up here. This is going to be straight graphing calculator. We're not drawing anything here on our papers. There's no drawing. In the book and the homework, by the way, they give you graphs that you just tell if it's bell-shaped or symmetric enough. And what you're trying to do is look to see if it's wonky enough to rule out being normal. So I already put these in L1, and then I went second, y equals, and I turned my first plot on to be a box plot. And I turned my second plot on to be a histogram. So I could get a combination histogram box plot. And then I just let the calculator pick the scale and I just hit zoom 9. And what I'm doing here is I'm saying, if I had all the numbers, is this like ridiculously skewed one way or the other? Unfortunately, no. I can't rule it out. It might be normal. I'm not sure. So I'm writing, number 1, I check the shape. The shape is inconclusive. Remember that it's a sample. I can't really tell. It's not enough information for me to determine if it's normal or not, but I can't rule out. Oh, I already screwed it up. Do you see where I screwed it up? I didn't capitalize my N. I said I was going to do it all chapter. Okay. Oh, I did the first test already. Okay. The next test is the empirical rule. When you guys do AP Classroom at the end of the chapter here, and AP Classroom asks you to decide whether or not data is normal, this is probably going to be the way that they ask for it. Okay, let's run one variable stats. You guys know how to do that? Let's make sure we all put the same data in, first of all. Stat, calc, one variable stats. Did we get the same thing? 15.5385? Anybody? Okay, so I got the mean is 15.5385, and the standard deviation is 4.9071. Okay, so 15.5385 plus or minus one standard deviation on either side. What percent of values should be within about one standard deviation of either side? 68% of values, right? Okay, now if I do 15.5385 minus one standard deviation, how many of my numbers, how many of my data set are within this range? Okay, let's see. 1, 2, 3, 4. Nope. Nope. 5, 6, 7, 8. Nope. 9, 10, 11. Nope. Nope. Please stop talking. 12, 13, 14. So 14 out of my 20 numbers are in between this range. Which is pretty close to 68%. This is kind of indicating that we might be normal. Can you tell what I'm going to do next? Now I'm going to check two standard deviations out. And this is just my pure laziness. I'm going to scroll up and change this to a 2. So I already know the 14 that I put dots next to. So now I just need to see any additional ones. So 15, 16, 17, 18, 19. Okay, is that what we expect? Because it goes 68, 95, and then what? 99.7, beautiful. Mm-hmm. The empirical rule. Look back at look back at 2.2b right here, 68, 95, 99.7. It's about 100%. Do you remember? Okay, and I know you because you're all really good students and you're gonna say, Mrs. Talbot, how close do these need to be? I mean, kind of like that close. I'm not shocked that 100% of the values are in there. 100% is really close to 0.997, right? 70 is not far off from 68. Don't get freaked out by that. It's just, this is pretty good. It's like you'll know, or you'll know if it is, or you'll know if it's really off. Okay, and then you make a conclusion. It's pretty close to the empirical rule, so normal-ish, normal. Okay, and then the last bit is a graph that you can do on the calculator called a normal probability plot. This is the very last thing I'm teaching you today. I'm going to teach you the calculator strokes here. Almost done, guys. You don't, by the way, have to be on plot one. I just like to be on plot one, but you don't have to be. Okay, so let's practice our calculator strokes here. We already have it in L1, right? Second, y equals. You can be on plot one, hit enter, turn it on, and then you want to go to this guy over here, which is on the very right picture. So I'm gonna scroll all the way over to this guy here, the very right one, and select that. And then zoom 9. No, doesn't he know? It's Guinan. I'll call him back. Okay. Zoom 9. And what you're looking for is a line. If it's a line, then it's normal. If it's a curve, it's not normal. I'm going to show you one out of the book that's not normal. This one is pretty linear. Did you guys get it? Did you see that it was linear-ish? Okay, let me show you one in the book. I just grabbed the book here so you could see a difference. This guy is not normal. Okay, because it's got a big curve. And actually you can tell because the curve's up at the top, that would mean the tail is up to the top. So if this is the normal probability plot, then here is the original data. So you can tell tail is going to the right. In this case, the tail is going to the right up top. Okay, so line is good for normal probability plot. Yes, honey. I don't know what the thing would be if it was uniform shape. We could play with it. These guys up here are all good enough. It says, although none of the plots is perfectly linear, it's reasonable to believe that they came from a normal population because it's just a sample. It just can't be like, whack. Does that make sense? So don't expect perfection. You're in stats, but it should not, this is a problem. Alrighty. All right, that's it. That is chapter 2.